Hi, I'm Ellen Stofan, the John and Adrian Mars Director of the Smithsonian's National Air and Space Museum. I'm Dr. E, and we're here for another episode of Easy Science.
Hey, and I'm Thomas Zurbuchen, the Associate Administrator for Science at NASA, also known as Dr. Z.
We're here today to talk a little bit about something that people probably don't think of as being that important in their lives. But if, for example, you use some app to help you get to where you were going today, you're actually relying on NASA understanding the sun.
So we're looking at our star, our favorite star, the sun, and we see that the star is a magnetic star. You see, as the sun is boiling at the surface because it's so hot, it's carrying with it magnetic fields. And like little arcs, they're there and they're interacting with each other, liberating energy, UV energy of the type that, of course, burns your skin, an X-ray like you see at the doctor. That kind of radiation is coming from the sun and it's spreading around, causing what we call space weather. Of course, as it's heating out that atmosphere, the corona, it's also blowing away its atmosphere. It cannot hold on to it and it's filling the space between the planets.
Now that space weather is what can disrupt our communication satellites, our GPS satellites. For the astronauts up on the space station, they even have to worry about what's going on the surface of the sun.
Exactly right. And when they're leaving to go to the moon or to Mars, that is even more important because now we're away from the magnetic protection of our Earth.
Now, NASA has a lot of spacecraft studying the sun, and they get as close to the sun as they can. But right now we have a spacecraft up there that's doing something pretty special. Can you tell us about the Parker Solar Probe?
It's really the first spacecraft to touch the sun, to fly through that corona, through that atmosphere, and sample it in a way that we've never seen it. So in fact, it just completed its third orbit by the sun, and it's collecting data and sending it back to Earth. So we're learning about this atmosphere in a way we've never seen before, just now.
I think a lot of people don't recognize that when NASA does things like go to a planet or get really close to the sun, we have to push technology in ways that you just don't normally have to do, which then spins off and benefits us right here on Earth.
Absolutely. A lot of these materials that are being developed right here for Parker Solar Probe and were developed in the last decade or so are materials that are very much applicable in other systems like energy systems or even firefighting type of applications where those kind of materials matter, for example.
Now, we did get a question so that someone sent into Easy Science, so don't forget about sending your questions in for future episodes. Parker has gathered some information about why the sun's corona is hotter than its surface. Tell us a bit about what it's found in its first year.
What we're learning about is that the near corona, like right down there by the sun, is a lot more turbulent, a lot more interactive than we thought before.
This is a spacecraft that was named for a living scientist, and can you tell us why we did that?
Eugene Parker is so important for that entire field. He's the guy who predicted that the solar atmosphere would be blown off into a supersonic stream, the solar wind. Highly controversial, and of course he was right. In fact, there's something like 35 spacecraft in all of NASA's inventory that are dealing with things that Parker predicted. And I will never forget how Parker looked and his family when the rocket went into the sky with him seeing his spacecraft leave the Earth. I'm going to ask you a second question, that is, how does the research in space help prepare humans on a journey to future Artemis missions to the moon, Mars, and beyond?
So the more that we can monitor the sun, the more that we can understand and predict what's happening at the sun, the better we can do with protecting the astronauts. Now, if we know there's a solar flare or particles coming towards them, they can go into areas that are shielded, and those are some of the technologies we work on, is how do we protect astronauts from this space radiation, both from the sun but also from galactic cosmic rays. We're going to be able to do that research even better on the surface of the moon outside of our magnetic field, whereas Thomas said the astronauts are much more vulnerable. Now, Thomas, some of the surface science from Artemis is also going to help us eventually get to Mars.
Of course, as we're sampling the surface of the moon, what we also will be able to do is look at the components that are in there, especially water, that we may be able to use both on the moon and Mars over time to live off, but also make fuel out of it. So it's really exciting.
Well, I'm afraid we're out of time, and thank you. This has been incredibly fun to talk about our favorite star.
And I really want to encourage everybody to send questions again, questions that we'll answer on the next episode of
Easy Science.